Welcome to another episode of In Depth with Academia. I'm Richard Price, CEO of Academia.edu, and as always, my goal is to bring you intriguing new research in a way that's open, lively, and a bit more digestible than your average academic conference. Remember, I'm presenting today's featured paper and its ideas in a neutral way. I'm not endorsing everything you'll hear, but I think it's worth hearing about and reflecting on. Today, we're taking on a classic problem in physics and philosophy, one that literally touches every part of our lives. I'm talking about the nature of time. Specifically, I'll be summarizing a paper by Filippo Pilotta that asks, what is time? Let's set the stage. We've got Newton on one hand, proposing an absolute, rigid time like some master cosmic clock. Then Einstein jumps in, and with relativity, time becomes relative, splintered by your motion or where you're standing in the universe. Each observer pretty much has their own wristwatch, ticking to its own beat. But wait, Pilotta's paper says, what if both of these ideas miss something crucial? What if there's a third possibility, a kind of cosmic time, that's not just absolute and not just relative? That's the core question. Pilotta introduces what he calls Relatività Comune, or common relativity. And he's asking, can we have a truly measurable, physical structure of time that's not just a psychological illusion, but also not something totally external and rigid? The proposal is centered on this idea of a cosmic time field. That's T0 if you're into symbols, which organizes the unfolding of the universe without being some outside coordinate. Instead, it kind of bubbles up from the overall coherence and entropy, the internal disorder of all physical processes. So it's grounded in physics, but it's also sort of an organizing principle. Why is this significant? Well, think about it. If time isn't shared, there's basically no way to talk about now in any objective sense. No way for scientists in different labs or for two people on different planets to agree on what's happening right now. That really messes up our understanding of objectivity, measurement, and even communication. If you care about how science works or about the possibility of, say, time travel, this actually matters a lot more than you might think. Let's talk about Pilotta's approach. He suggests that this cosmic time, T0, is a kind of hidden structure that we can detect indirectly, mainly by observing global entropy. Entropy is a measure of disorder, right? So as the universe evolves, entropy increases, just like your bedroom getting messier and never spontaneously tidying itself. In Pilotta's framework, the direction of this increase, the arrow of entropy, isn't causing time, but it's the best sign we've got that time is moving forward in a cosmic sense. So the key insight, this T0 field, slices up space-time into sheets. Think pages in a cosmic book that represent moments of shared now across the universe. Every observer's own local time is just a projection of this cosmic clock. It's like seeing a shadow of the same thing, but from your own vantage point, and you can have all sorts of differences, dilations, slowdowns, depending on where and how you move. But you never break from this global record of the universe's history. Interesting, right? And get this, Pilotta claims this structure helps clear up some real headaches in modern physics. It rejects weird time travel scenarios like those infamous closed time loops you get in mathematical solutions of Einstein's equations. The idea is these aren't just out there as some wild possibility. The rules of cosmic time kick them out. Time runs one way, and you can't just jump back because, well, global entropy won't let you unscramble all that info. Now, this cosmic time doesn't just affect stars and galaxies. Pilotta spends some time, no pun intended, talking about living systems, even consciousness. He suggests that local biological clocks, like in your cells or in your brain, are projections of the cosmic time field filtered by your complex internal structure. So the now we feel in our minds is related to, but not identical to, the big cosmic now. I mean, that's a wild thought, and it makes me wonder if, when my coffee wears off at 3 p.m, that's my own personal T0 going haywire. Just kidding, or maybe not. Let's just step back for a sec. I want to remind you, this paper doesn't claim to have the absolute truth about time. It's proposing a framework, a way of thinking. Academic research, especially in philosophy or foundational physics, isn't about nailing down the answer. It's about opening up new ways to look at old problems, and maybe to help you, the listener, think a little differently about questions you bump into every day. Like, when you stare at a clock or your phone, and you wonder why time feels so slippery, and weird sometimes. So what could this mean for you? Well, even if you never touch an equation, the idea that our sense of the present, the whole "I'm here now with everyone else," might have a shared physical basis is kind of reassuring. And it's also a reminder that objectivity in science might rely a lot more on the structure of time than you'd expect. Or, maybe you'll just use this as a conversation starter the next time somebody brings up time travel movies at a party. Anyway, thanks for joining me for this episode of In Depth with Academia. As always, I'm just presenting this for your exploration. No endorsement, no dogma. There's so much more to say about time, relativity, and our place in the universe. And, well, I hope you'll keep thinking, keep questioning, and stay curious. See you next time.